All right, coming to you live here from KubeCon 2025 in North America in Atlanta, Georgia. I'm here with Brian Verkley. Brian, how are you?
Very well, thanks.
That is awesome. So we used to work together for a while over at Dell, and now you are at Vast,
I am.
and you're wearing your Vast vest. And you said you've been there about a year.
Yeah.
What does Vast do? Tell us a little bit about it.
Sure. It's a data storage. It's mostly used for artificial intelligence, and so we're branding it as uh, the operating system for AI.
And so, as I just found out, that you have no hardware, you're just software.
That's right.
So what type of hardware do you run on top of, and how do you work with it and integrate?
Sure. The hardware can come from many different vendors. Comes from Supermicro or Lenovo, Dell, and on and on. And we're kind of prescriptive about what the hardware is, so we're happy to work with you, and we understand sizing and requirements to understand what those part numbers are, so that you can get the right hardware, and then we will support it in the end as an appliance. So if there's any kind of problem, you call us. If it's software, we can fix it. If it's hardware, sometimes we can fix it, or sometimes we'll direct you. But there's no finger pointing or passing it around. It's always going to be our problem.
So one of the things I'm assuming then is that the value add is you come out, look at customers' environment, and then give your recommendations. And how much do you go beyond what you all do and give them broader architectural advice?
Broader architectural in the sense of what should be outside of these systems.
Right.
Sure, we it's always about the delivering a quality end product, right? So our product is used underneath a lot of NeoClouds, for instance, and so we care about making sure that the storage is fast enough and for the use cases. We care about making sure that the data flows and the data pipelines that run on top can run excellently. We care about the networking that connects to it, and we'll be a participant in that whole system to make sure that the end product is as high as quality as it can be.
So when I think of this space, I think of obviously you all, and then Weka and DDN,
Sure.
and to some extent Hammerspace. So how would you position yourselves against these players?
So there's kind of couple different categories of competitors that we have. I wouldn't say there's any one that sort of matches up cleanly. There's some of them that you mentioned that come from that HPC space where they've been building these top fuel dragsters for a long time, and that they can go really fast for the job that they're being used for. And other competitors, you might see Dell or Pure or NetApp or whatever that's built enterprise infrastructure for a long time, and they have some different like enterprise type features, but they don't have the same features that HPC would have. Whereas we get to have both of those, enterprise class features across the whole set, multi-tenancy and things like that, but also very scale out. So maybe it's implied by our name, but petabytes to exabytes in a single cluster, very scale out system. And so we can solve all those kind of use cases, and then we take it a step higher. That's where we're getting into that AIOS, the AI operating system. Instead of
Yeah,
just
if
having,
that was announced not too long ago,
yeah,
correct?
that's right.
So yeah, if you just sort of double click on that and just give a broad explanation.
So you start with your data, but then you want to have the layer on top of that. So we can speak block, file, and object, obviously, as other storage systems can. But if you want, you can also write tables, SQL, to us. And in the end of the day, data is just data. It's just another protocol that moves it to us. And so we'll speak SQL. We'll also do things like a Kafka-compatible message bus. So you can send us topics and we'll store them as data in a very scale-out manner across the infrastructure. And then the database now is extended to be a vector store. So if common in AI is you want to store vectors, and you can do the same thing on our system. And then now you've got that data layer, so you can activate all that data. And then we want to take it one step further to say, now you want to build a pipeline of data flow. So a very common thing that somebody might want to do is when a new object shows up in a bucket, you want to send it through a system, a number of different steps where you maybe chunk it down, you do a deduplication or a PII filtering, and then you create vector embeddings, the semantic understanding of the file, and store that back in the vector store. So now when you want to do your retrieval augmented generation, your RAG pipelines, you already have those vectors available. Because it's all happens in one system, one trust zone, you didn't have to send your files somewhere else and then have them come back and hope that they weren't seen or touched along the way. But it's also that metadata of the the vector information becomes like metadata for the file. So
Okay.
if you have access to the file, you have access to the vector semantic understanding of it, and if you don't, you don't, which you don't get when you have them in multiple systems. So we start with that data storage and those competitors that you talked about do data storage, and then we extend that in layers higher, moving towards the application space.
So I've heard it said that if you don't have a data strategy, you don't have an AI strategy. You probably
Yeah, I like that.
coming from your space, you probably believe in that. What? How do you get data to the various places it needs to be with, and how do you unify it and all that good stuff, just at a high level?
Yeah, so we sell software, not the hardware itself, and so most of our customers will install that in their own hardware on their own prem. We also power a lot of the NeoClouds, and so if you don't need to run your own infrastructure or don't want to, you can run it there, still running on Vast. And then we can federate between some of those clouds. So we'll build what we call data space, which is a global namespace.
Hmm.
So you can run in Google Cloud, for instance, as well as on-prem. And or as well as at a NeoCloud, and have them all stitched together in one global namespace. So the idea that your AI inferencing, those workloads, might need to have different geographies running in different places, and yet still have access to the same data, because your AI problem is your data problem. Maybe you don't want to have those data copies and the data copy management and the security implications that come with that. Just simply have a single global namespace, all connected by Best.
And so, to what extent are you focusing on NeoClouds as your customers? In other words, for end users, they don't care what's under that. They just want to make sure that the GPUs that they're using run efficiently and quickly. And to what extent are you going into large enterprises or smaller enterprises and selling it to them?
I think in the AI space, we've seen a lot of training leading inferencing, meaning there's people are spending a lot of money to build infrastructure and to build these models that then you can use in the enterprise space. And so our currently the bulk of our customers have been NeoClouds, and those who are building those kind of infrastructure for frontier level models. But it's shifting this year, and I expect it to shift even more next year as more enterprises are moving into adopting more AI, using more AI inference. That I think the balance will shift a little.
Okay, just zooming out here for the last section. Now, you believe that all LLMs are going away, and we're going to small language models. No, I think it's bifurcation you were talking
It
about.
is bifurcation.
How do you see AI at a high level evolving?
I was at a PyTorch conference a couple weeks ago where somebody was explaining that they had built into an LLM the ability to use robot arms, so they can control the robots from the LLM. And they took that to labs who were building custom robots to do individual tasks for weeks, months, years, and their LLM uh, outperformed it without having been trained on that individual task, because the LLM is that giant brain that understands a lot of different things, and can make connections between different properties. They're sorting fruit in one example, and so it knew what an apple was, and had guesses about the properties of that apple, size, weight, things like that, and so it could make good guesses about what the robot arm should do in order to do that. Whereas training the robot arm specifically for how to handle an apple versus
An
a soft
orange.
body like a T-shirt,
Right. Okay.
very very different
Right.
kind of use cases, was difficult. So I think that LLMs, those giant brains, because they're trained on many different things, are going to be in control of the macro use cases, and then the little bits, the little robots, whatever the tasks,
Hmm.
whatever the tools that we might use, um, they'll be kind of local and small LM based.
Cool. Brian Verkley, thank you so much.
Anytime. Happy to see you.
Good to see you.